In this video we're going to talk about depreciation. Depreciation is the process or the phenomenon where things lose their value. So you might buy a car for a certain amount of money, and when you buy the car, well, at the moment you buy the car it costs whatever you pay for it, but as soon as you drive it out of the car yard, then it's going to lose some of its value. It's not going to be worth as much as it was when you bought it because of depreciation. Because people don't want to pay as much for old things as they do for new things, and the older something is, the less people expect to pay for it. So the value of things decreases over time. So let's say at the beginning the car costs $10,000. When you bought it, it cost $10,000. As soon as you buy the car and drive it out of the car yard, its cost is going to start going down over time. Its cost is gradually going to decrease. I've shown it here decreasing by a kind of steady amount. That's called flat rate depreciation. Okay, and that operates similar to simple interest, but in reverse. Simple interest is when it gains a certain amount every period of time. Flat rate depreciation is when it loses a certain amount of value over time, every period of time. So that's flat rate depreciation. But sometimes things lose their value in a different way, more like a curve like that, and we call that reducing balance depreciation. Okay, reducing balance depreciation. So that's kind of the analogy, or it's similar in process to compound interest, where it doesn't lose a regular amount every period of time. The amount that the amount of value that's lost, the amount of depreciation, depends on what its value is at that point in time. Okay, so something that's already not worth very much isn't going to lose as much value as something that's quite valuable. So for instance, the day after you buy this $10,000 car, it's going to drop from $10,000 down quite significantly. Its value is going to decrease significantly just because it's now no longer new. It's just gone from being new to being old. So it loses quite a bit of value. But the difference between a car that's 9 years old and 10 years old, the difference in value there is not going to be as big. Okay, someone who's willing to pay, $2,000 for a car that's 9 years old, they're probably going to pay a similar amount for a car that's 10 years old. Maybe a little bit less, but not a lot less. They're not going to expect it to be much less than that. Okay, now we can represent the process of depreciation using a formula, and it's a very simple formula. We just need to look at the book value of the depreciation, of some sort of good, as its purchase price minus the depreciation. Okay, the book value means what its current value is, so we can say that book value is like the current value, and the book value at any given time is going to be the purchase price, or the initial price, minus the depreciation, which represents the drop in value. Okay, so that's very simple. The current value equals the initial value minus whatever drop in value has occurred, which is what depreciation is. And we can simplify this even further into a nice equation like this. V equals purchase price minus depreciation. So the book value equals the purchase price minus the depreciation. Now the book value, that's just going to simply be a number. So the current value of a car might be $5,452 at a given moment in time, and its original price might have been $10,000, and so we know how much depreciation has occurred. But often we won't know what the book value is. Often that'll be the thing that we're trying to calculate. We'll know what the initial price was, so let's say it was $10,000, and what we're going to need to calculate is what is D. Okay, we're going to have to find D. And for flat rate and for flat rate depreciation and for reducing balance depreciation, there's two different formulas to work that out. Let's look at those two different formulas. Okay, so here's the two formulas that help us to work out these two different kinds of depreciation. Flat rate depreciation, as we said, is very similar to simple, it follows the same kind of mathematical formula as simple interest, So depreciation equals the principal times the rate of depreciation times the amount of time. In this case, R is the rate of depreciation instead of the rate of interest. And so we can make our letters here. P is principal, R is rate of depreciation per annum, still needs to be measured per year, and T is time, which needs to be measured in years, and R is a percentage. And for reducing balance depreciation, you should notice that looks very similar to the formula for compound interest. The only difference being that instead of a plus, we've got a minus here instead. So for reducing balance depreciation, notice that this doesn't tell us what D is. This doesn't tell us the amount of depreciation. This tells us the book value of the depreciating item. The same as with compound interest, the formula gives us the total amount, the total value, not just the amount of the interest or the depreciation, which is what the simple interest formula does up here. So in this formula, V is the book value or the current value of the whatever the item is. P is the principal, that doesn't change. That's the amount of, that's the current value of the item, or in this case it's going to be the purchase price, unless we might actually be measuring the depreciation from one book value down to another book value, in which case the principal would be the current book value. R is going to be the rate of depreciation per year. We'll just write DEP per annum, per year, and that's going to be a percentage. And finally N is the number of years. Okay, lastly for this topic, we're going to look at unit cost depreciation. Okay, unit cost depreciation refers to situations where you've got something that loses value, it loses a certain amount of value every time it performs a task, every time it does some job. So let's say you're in a factory, you've got this machine, and this machine makes let's say paper clips. Okay, this machine makes paper clips, and every time it makes a paper clip, every time it produces a paper clip, it loses let's say 2 cents of value, $0.02 or 2 cents of value every time it produces a paper clip, because that's a way of measuring, how much wear and tear it's undergone, how much work it's had to do. Would you rather have a machine that's made one paper clip or that's made 1 million paper clips? Obviously the one that's made one paper clip is going to be in better condition. So it's a way of measuring that, this unit cost depreciation. The way it works is to ask, what was the initial value of this machine? Okay, when we first bought it, it was worth $1,000, let's say. And then once this machine's finished and it's no good anymore, and we're going to have to, get rid of it, then we might be able to sell it for, just a very low price, maybe $200, let's say. Okay, so if we sell this machine for $200, then the amount of value the machine loses in between is $800. Okay, that is the amount of depreciation that it undergoes. And let's say that in the lifetime of this machine, over the course of this time where it goes from being brand new down to when we've got to get rid of it as kind of scrap, let's say we expect it to produce 10,000 paper clips in that time. Sorry, I shouldn't have a dollar sign there. But we expect that machine to produce 10,000 paper clips before it gets to this stage. We know that's going to happen. Okay, if we take the amount of money that it's going to lose, the amount of value that it's going to lose, the depreciation, this is the depreciation here, the $800, and we divide that by the number of units that it's going to produce, the number of tasks it's going to perform. It's going to perform 10,000 tasks of making a paperclip. Then we can work out how much value it loses per paperclip that it makes. If we put this into a calculator, let's see what we get. Let's cross out those. So we've got 8 divided by 100. That means that the machine loses 0.08 cents per paperclip that it makes. Okay, every time this machine makes a paperclip, it loses 8 cents of its value. So that is the unit cost of this machine. Every unit or every paperclip costs 8 cents. And we can look at the situation another way by saying, if we know the unit cost, then we can work out the depreciation the machine will undergo by taking the unit cost, if we know what that is, and multiply it by the number of tasks. Multiply that by the number of tasks that the machine will perform over its lifetime. Unit cost times the number of tasks will equal the amount of depreciation. So in other words, this number, the unit cost, times the number of tasks that it will perform over its lifetime, which would be 10,000, would equal $800. That was the amount of depreciation. So in our case, 800 equals 0.08 times 10,000. Okay, and here's a summary of what we've looked at about depreciation for flat rate and reducing balance depreciation, the equations and the definitions of the terms. And so you can pause it there to copy that out, and then we'll show the unit cost summary. And there's the unit cost summary, just those two equations. And thanks for watching the video. I hope you found it helpful. Don't forget to look on the website for other videos of worked examples for these questions, for these kinds of depreciation problems, and also the quiz on this topic. Thanks very much.